Today we're going to be transforming square root and cube root functions. So your essential question is, how do I know what the transformations to a square root or cube root function are? So we're going to look at the basic general equations of a square root function and a cube root function. And each part of this tells us what the transformation of the graph will be. So first, if we look at the square root function and the cube root function, they kind of have the same thing. So I'm going to write on both of these at the same time. So if there is a negative sign in front, that tells us that there is a reflection over the x-axis. So it's going to flip over the x-axis upside down. Okay, and then this part in the center, the minus h part, that tells us if the graph moves to the left or the right. So if we look at the part underneath the radical sign, if it says plus, it actually moves to the left, and if it says minus, it actually moves to the right. It's the opposite of what you think because the formula has a minus sign in it. Okay? Then the number at the end tells if you go up or down. And this one is normal, so it would be plus if you move up and minus if you move down. Now, there's one more thing. This number in the very front tells us if the graph is going to stretch or shrink. Okay? Now, you don't pay attention to if that number is negative or not, because the negative part is talking about if there's a reflection or not. So the value of a, if a is greater than 1, then it's going to stretch by that factor. And if a is less than 1, then it's going to shrink by that factor. So let's look at some transformations of graphs. So first we have our square root function. Okay, so we're going to graph this square root function and give the domain and range, and we're going to describe the transformations from the regular graph of y equals the square root of x. So that's our parent function, and then we're going to figure out how did it change. Okay, so let's actually do that first. So that's going to help us graph this. So the negative sign in front means that there is going to be a reflection over the x-axis. Okay, then the 2 in front tells us that it either stretches or shrinks. So it's going to stretch because it's greater than 1 by a factor of 2. Okay, then we're going to look at this number right here. The minus 3 under the radical tells us that it goes right 3. It's opposite of what you think when it's under the radical. Okay, and then the last thing is this part right here, plus 2 at the end, means that it goes up 2. So the easiest way to graph these is to graph just like the parent function, and then we can just shift it right 3 and up 2. We can do the translating. I feel like that's the easiest way, but if you don't like this way, see me in class and I will show you an alternative. So first, we need to know what we're going to plug in for x. Now, I'm going to go back to the kind of like the parent function, but we're going to leave the negative 2 in front. I'm actually going to graph y equals negative 2 times the square root of x without the right 3 and up 2. That will make it a little bit easier to plug in numbers, and then we can just translate our points. So I'm going to plug in numbers that are perfect squares so that I can take the square root. So I can't plug any negative numbers in. I'm just going to plug in 0, 1, 4, and 9. Because those are all perfect squares. This is 0 squared, 1 squared, 2 squared, 3 squared. So the square root of 0 is 0, times negative 2 would still be 0. And if I plug in 1, the square root of 1 is 1, times negative 2 would be negative 2. The square root of 4 is 2, times negative 2 would be negative 4. The square root of 9 is 3, times negative 2 would be negative 6. So I'm just going to plot these points, but I'm not going to connect them just yet. Okay? So I'm going to plot 0, 0, 1, negative 2, 4, negative 4, and then 9, negative 6. Now, I'm not going to connect them yet because I actually didn't want to graph this. I actually wanted to graph this equation up here. So I need to translate all of my points right 3 and up 2. So I'm going to grab another color, and if you're doing this, you can do it in 2 different colors if you'd like, so it's easier to tell where your points are. So we're going to shift everything right 3 and up 2. So 1, 2, 3, up 2. 1, 2, 3, up 2. 1, 2, 3, up 2. And then that one won't fit on the graph. So this is actually my graph, the red one. So now I need to talk about domain and range. Now remember, domain is associated with the x value and range is associated with the y value. So for the domain, if I look, where does my graph start when I'm going along the x-axis? Okay, if I go along, I don't have any negative numbers and I don't have 0, and it starts at 3. So, and it can be equal to 3 because I have that point on there. So my domain is going to be x is greater than or equal to 3. Okay, if you wanted to write that in interval notation, that would be from 3 to infinity. So either way, okay? Then the range is what it can equal for y. Now if you look at your y value, it starts at, and remember this is y going this way, it starts at 2 and then it goes down from there. So it's going to be y is less than or equal to 2. Or you can write that from negative infinity to 2. Either way, however you'd like to write it. Alright, now let's try the same thing, but with a cube root function. So first let's list the transformations. Okay, so we have this one first. So that means, that number in front means that it stretches by a factor of 4. Okay, then I have this plus 1 in here. That means that it will go left 1 because it's opposite of what I think. And then the last one is that it will go down 3. Okay, so those are my transformations. So when I graph this, I'm just going to graph just this portion. So I'm really going to graph y equals 4 times the cube root of x, and then I'm just going to translate it left 1 and down 3. Okay, so I'm doing cube roots now. So I have to plug in numbers that are perfect cubes. So remember, cubes can be cube roots can be negative, 0, or positive. So negative 2 cubed would be negative 8. Negative 1 cubed would be negative 1. Then 0 cubed would be 0. 1 cubed would be 1. And 2 cubed would be positive 8. So this is what I can plug in for my cube root functions. So if I work this out, the cube root of negative 8 would be negative 2 times 4 would be negative 8. The cube root of negative 1 would be negative 1 times 4 would be negative 4. The cube root of 0 is 0 times 4 would be 0. The cube root of 1 would be 1 times 4 would be 4. And the cube root of 8 would be 2 times 4 would be 8. So I'm going to graph these points, but remember I'm not going to connect them yet because I'm going to have to translate them. So I have negative 8, negative 8, negative 1, negative 4, 0, 0, 1, 4, and 8, 8. So I'm going to translate each of these points, left 1 and down 3. So I go left 1, down 3 would be off the graph, but it would be about right there to give me an idea. Okay, then I would go left 1, down 3, left 1, down 3, left 1, down 3, left 1, down 3. And so the red points connected would be my graph. And you'll notice it's really big because remember it was stretched by a factor of 4. So it was stretched quite a bit from its original version. Okay, now let's talk about domain and range. So remember domain is associated with the x values and range is the y values. So if I go across the x-axis, I have numbers this red goes all the way across. So I can plug in any number I want, all real numbers, or you can do from negative infinity to positive infinity. Okay, for the range, if I look at the y's going up and down this way, my graph goes all the way across. So my range is also all real numbers, or from negative infinity to positive infinity. All right, so be sure to go back and answer the essential question and write your summary. Thank you.